right, so the last issue for factoring, we've learned how to factor two-term polynomials with our factoring patterns, right? Sum and difference of cubes, difference of squares, and there is no sum of squares pattern. We talked 2 days ago about how to factor three-term polynomials, trinomials, and found that if we're tricky about it, it's unit 4, right? It's just unit 4, but instead of using x's, we might have packets of x squared or x cubed or something, right? But it works the same way as factoring regular trinomials in unit 4. And now we're going to talk about four-term polynomials. So this is a technique called grouping, and this is for four-term polynomials, okay? Now we're going to start with the steps that they give us, but we can make these a little better. We can do better than this. So we're going to make a couple little changes. So you might want to get out your notes and go to the page on factoring review, and it talks about four-term and factoring by grouping. We're going to make a couple little changes here, and then these notes will be. I'll put these up on online too, so you'll have access to these as well. Okay, so first of all, if you got four-term polynomials, we're going to group these into two groups of two terms. We're going to take the first two terms and put those together in one group, and we're going to take the second two terms and put those together into the second group. Okay. What do we do then? Okay, well, we're going to focus on the first group, right? So we're going to factor the GCF, but not for each group. For group 1, we're going to factor out the GCF. So looking at the first two terms, what is the GCF? X squared. Yeah, everybody agree that's the biggest thing we could undistribute. So we factor that out. And then what's left behind if we factor that out? Okay, good. X squared times x would give me x cubed, and then plus 1. X squared times 1 would give me x squared, right? Okay, now here's where things get a little different from what they do. If factoring by grouping is going to work, then the binomial factor, right, the leftover factor that we get is going to have to be the same in each group. So what we do to make this the easiest possible way is we're just going to copy that binomial factor over to group 2. But we've got to ask ourselves then, so this is a question. We have to ask ourselves, is it possible that I could undistribute something that would work to make that happen in group 2? Okay. In this case, it is, right? The easiest way to tell would just be to say, okay, let's look at term 3. Let's look at the first term of the second group right there, right? What times x would give me negative 4x? Negative 4, right? Okay, so then that's what we'd have to have for term 1. If we distribute that, we get negative 4x. Well, then just distribute it to the other term and see if it gives you what it's supposed to give you. And it does, right? We get negative 4. Okay, does that make sense to everybody? So when we copied that blue binomial over to this one, we were able to make that work if we factor out a negative 4. Okay. Now, one thing that's also kind of helpful to do is I'm going to put a plus sign in the middle of the two groups that separates those two groups. Now I always put a circle around it so it's easy to spot. There it is, right? So now we've got first group plus second group. Each of the two groups at this point has some GCF and the same common binomial factor, right? Okay, so then all we have to do now is we're going to undistribute the common factor, which is the binomial one. We made it that way, right? We made these two be the same in the process of factoring by grouping. So we'll just undistribute that from the first and the second groups. And what do we get? Well, we get x plus 1. Now, what's going to be left behind? From the first group, if I undistribute the x plus 1, what's left behind? X squared. Whoops. Okay, I've got my plus sign that joins the two groups. And then what's left over from the second group? -4. Right? Everybody see that? See how that flows? And there it is. It's factored. X plus 1 times x squared minus 4. Okay? Make sense? Okay. So we'll add kind of a fourth rule here. Both groups must share the same binomial factor. If factoring by grouping works, that's going to be possible, which it was, right? If it's not possible, factoring by grouping fails. Okay, yes, sir. Then it doesn't factor. Then you're not able to factor that 4-term polynomial. Okay. Yeah, you just write it the way it was. It's already prime. Now it's possible that there could be some other ways to factor that, but we don't know them at this level. So for us, it would be prime. We don't have the tools to go further with that one. Okay, if factoring by grouping fails. Okay, so let's try this guy. Okay, so we're gonna break it into groups. You guys want to try it on the board? Okay, go for it. Try it on the board, and then we'll go through it together. Try it on the boards. Okay, what did we do here? So help me out here, Persephone. What did we do in group 1? Okay, so you factored out a GCF of 8x cubed. Good. Which left behind what? X plus 9. Good. Okay, so here's going to be our special plus sign that separates the two groups. Right? So we'll put that one there. Now talk to me about group 2. What's happening in group 2, Andre? Okay, yeah, good. We know that guy's got to end up being the same over here. And then we just have the question, can we do that? Could I put a number out front here that when distributed would work? 1. Yeah, right? And we can check that and it works. 1 times x is x. 1 times 9 is 9. So it all works, right? So factoring by grouping worked. And then let's see, last step in factoring by grouping would be what then? What's that going to be, Peyton? Factor what out? Yeah, good, which is the binomial one, right? The x plus 9, the leftover binomial. So that guy's coming out front. And we're left with, what's left behind? Well, we've got this. We've got this 8x cubed, right? Plus 1, right? Okay, good. Everybody factored by grouping correctly, but nobody actually did what I asked him to do. Yeah, what, huh? It said completely factor the polynomial. So you guys all did the factoring by grouping process completely. And I get it. That's what, I probably have done the same thing. That's what we're practicing. But if I were going to completely factor this like I will on the test, right? Could I go further with that? Yeah. Which of those, the blue or the red, could be further broken apart? Ah, okay. Yeah, the red one fits the sum of cubes pattern, doesn't it? Right? I could think of that red factor as being something cubed plus something cubed. Well, 1 is what cubed? 1. Okay. 8 times x cubed is what cubed? 2x. There we go. Okay. So there's a sum of cubes pattern, right? So let's see. Lily, help me out with that. If we split this thing up, how's that sum of cubes going to factor? It's a cubed plus b cubed. A is 2x, b is 1. Good. No, okay, the first one is the one where it's just a plus b, right? So 2x plus, okay, well, it's just going to be a plus b. Well, a is 2x and b is 1, right? So 2x plus 1 is the first one. Kyler, let's get the second one. How about that quadratic one? What's that one going to be? Okay, good. The quantity 2x squared, right? So the quantity 2x squared is going to be what? No. I got to square the 2 and square the x. 4x squared. If I square the 2, I get a 4. If I square the x, I get an x squared. Good. Okay, keep going. There's your a squared. Keep going, Kyler. You're doing it. 2x, yeah. 2x times 1. AB is 2x. And then a squared minus AB plus 1 squared, which is 1. Good. Okay. And then don't forget, we've got this x plus 9 factor that was already done, but that's part of our answer too. So we broke this 4th degree polynomial down into 3 pieces, 3 factors. That's good. That's as far as we can go. Okay, give me one. That makes sense. Okay. All right, let's try one more of these here. Now let's do this one together real quick because I want you guys to see something. I want to be able to point it out when we do this one. And I'll give you another shot at doing one of these on the board if you wanted to. So what about this guy? What's focusing on the first group? What's the GCF of the first group? 5x squared. So distribute a 5x squared, which leaves behind what? 5x squared times what is 5x cubed? X plus 2. Okay. Okay, so now we've got our plus sign in the middle. And if that were a minus, then I'd have to just make that a plus negative, right? I'd put the plus in front of the minus sign, right? Okay, so there's my plus. Now, what has to happen in group 2 again on this one? Veronica, what am I doing here? Okay, good. I'm going to move that x plus 2 over. And I'm going to ask myself, could I make this work? Well, let's see. What would I have to give me a 2x? 2. Okay, let's try that. So if I distribute the 2, yeah, look at that. I get 2x. If I distribute the 2, do I get 6? Uh-oh, problems. Right? Didn't work. Okay, so what's the story here? What do we say about this one? Yeah, doesn't factor. Okay. Now, there's a way we could have predicted this. There's a test we can do if we want to without having to do all this work that predicts whether factoring by grouping is going to work. I just call it the factoring by grouping test. For a 4-term polynomial, if we write it in standard form, it's got to be written in standard form where the highest power of x first and so on. If we look at it this way, so I've got the first 2 terms plus the second 2 terms. Let's make the first group yellow and the second group green. The factoring by grouping process is always going to work if the ratio of term 1 divided by term 2 is equal to term 3 divided by term 4. If that happens, it's guaranteed to work. And sometimes it's difficult to simplify fractions like that. I mean, it's really not that bad. But if you want to avoid that, I have a ratio here, so I could always just cross multiply and see if the cross products are equal. That's an easy way to check, right? So let's show that this worked for the first case, but failed for the second one we did. This was the first problem we did, right? If I take the ratio of term 1 divided by term 2, is that equal to term 3 divided by term 4? Well, you could look at this and just cancel some things and say, pretty easily say, yeah, it works, right? x to the fourth. I always break it up this way. I think of the numbers and the variables separately, right? And I always try the numbers first, because if the numbers fail, then you might as well stop. Then you know it's not going to work. Is 8 divided by 72, 8 over 72, is that the same as 1 over 9? It is, right? So the numbers pass. Now do the variables work? Is x to the fourth over x cubed the same as x over 1? Yeah, so it does work. If you don't want to go through that process, just cross multiply. Just do this. So is that cross product, which is right there, the same as that cross product, which is right there? Yeah, they are. And multiplying is easier than dividing, isn't it? So 8x to the fourth times 9 is 72x to the fourth. 72x cubed times x is also 72x to the fourth. Check. It works. Okay? So that one's guaranteed to work. Okay, how about the second one we did? Term 1 divided by term 2, is that equal to term 3 divided by term 4? Well, right away you can see we've got problems, right? Look, 5 over 10 is not the same as 2 over 6. So you already know it's going to fail, right? They would have to be in the same ratio. That's why I always look at the numbers first, okay? If we do the cross product, we can see it this way also. That cross product is clearly going to end up being different than that cross product, right? This is going to give me 30x cubed. That gives me 20x cubed. Those are not equal, so that one fails. Okay, good? All right, last example. I'll let you guys work here. So I want to look at one where there's a little more to it, where we're going to factor one, where factoring by grouping is just part of the big process. So this is a pretty good sized polynomial we've got to factor, but you have the tools to do this. What do I always want to do first when I'm factoring? Greatest common factor. So is there a GCF that I can undistribute? Say it again. 3x what is it? Squared, yeah. Squared is the biggest x I can take out. Okay, here's the question I got for you. The leading term is negative, so what should the sign of the GCF be? Negative, right? So here's the kind of the rule that we have. And we haven't really had to deal with this much in the past, but now we're getting to where it's going to be more useful to us. When we factor out a GCF, we always want to keep the sign of the leading term with the GCF. So we're going to factor the negative out, okay? How come? Because we'd rather have when we're factoring by grouping, we'd rather the first term be positive. It makes things a little bit easier, right? So we end up then, when we factor out our GCF, we're going to factor out a negative 3x squared. And that's going to leave behind a bunch of stuff. Now, if you're having trouble finding what's left when you factor out a GCF, remember, you can always just divide each term by the GCF to see what you get, right? Like I could, if I wanted to, I could divide this guy. Let's find some, what's a really light color, that guy. I could divide each of these by negative 3x squared to figure out what's left behind. What is left behind then? X cubed, right? 18x to the fourth divided by negative, so I'm going to get negative, aren't I? Positive divided by negative, 3x squared. What's that? Negative 6x squared. If we do the same thing here, negative divided by negative is positive. 75 over 3 is 25. X cubed divided by x squared is x, okay. Positive 450 divided by negative 3, so it's negative 150. There you go. Yep, 150. And x squared divided by x squared cancels, so I just get a 150. Okay. All right. So
now are we actually factoring it now?
Say it again.
Are we actually going to factor it too?
Now we're going to factor by grouping. Okay. Sometimes you guys, and this is not just you guys, this is like my calculus class too. Sometimes high school students get lazy about these brackets, because I get it. You guys are task oriented. You're good students. You want to just get down to business. But why are those brackets important? Say it again. Well, okay, sure, but then even if this were positive also, we still have to have brackets around all that. How come? To do what? Yeah, to separate the two. What would we call those things? That's one, and this is one. What are those? No, terms are things that are added. Those are not added. I mean, true, they might be polynomials, but that's not the word I'm getting at. What do we call things that are being multiplied? Things that are, well, I mean, that's true too, but things that are being multiplied, we call factors. We say a product is when we multiply stuff, right? We find a product. But the parts of a product are the factors in the product, right? Factors are things that are multiplied. So how many factors are there up there? Two. There's that pink one and the white one. The white one's just one big factor because it's being multiplied by something. Everybody get that? So when we have an individual factor there, it has to be enclosed. So we'll put this one in brackets because it's so big, right? You everybody get that? Like if I didn't have the brackets there, that would be like telling the math gods that this negative 3x squared is only being multiplied by the x cubed, but it's not. It would have to be distributed to everything, and that's what the brackets tell us. So we have to keep those brackets there. All the factoring by grouping stuff we're about to do is happening inside the brackets, okay? All right, so inside the brackets then, we got some stuff to do. GCF of the first group, x squared. Okay, good. So we've got, here's our first group GCF. Kiana, what's our first group leftover going to be? What if I undistribute an x squared from those two, what am I going to get? X squared times what is going to be x cubed? X, good. And then minus x squared times what is 6x squared, negative 6x squared, or 6x squared? Yeah, 6. Good, so x minus 6. Good? Okay, good. Owen, what happens next? Okay, good. Yeah, can't forget that plus. Put the plus in the middle. And we're going to scoot this guy over. Okay, and then we ask ourselves, could that happen? Could it happen? Well, what would have to go there? 25. And let's check it. 25, if I distribute it there, I get 25x. If I distribute it to the negative 6, I get minus 150. It works. Okay, so factoring by grouping worked. What can I factor out of the white brackets? What do you think? Treasure, what could I factor out of each group there? Let's look at each of these two groups inside the white brackets. In the first group, how many factors are there in this first group? Show me with your fingers, everybody. Yeah, 2, right? That one and that one. How many factors are there in the second group? 2. Okay, red one and blue one. Which one of those is common to both groups? X minus 6. That's the factor that's common to each of those two groups. So we're going to factor out the greatest common factor. That's it. We're going to pull that x minus 6 out front. And it's always going to be the binomial, isn't it? Right? Because we made it that way. Those two had to be the same. So we're going to undistribute this guy. And he's going to go out front with the negative 3x squared that's already out there. Right? So now we get negative 3x squared. We pulled our x minus 6 out there. And what's left behind then inside the white brackets? I said the white brackets right there. And what's left? Okay. So we get our x squared plus 25. Right? Now we don't need brackets anymore. Okay, can I go any further? Where? Okay, what pattern does that fit? Oh, Lily's shaking her head. How come? You're right. Say it again. It's positive. Yeah, there is no sum of squares pattern, right? A squared plus B squared doesn't factor. So we are donezo. Okay, good. All right, you guys can go to work. Good job today.